I now want to show you how to do time of flight calculations, TOF. Now these always look super overwhelming, but they are absolutely fine if you follow a few key steps. Remember, they're worth between 5 and 6 marks, so it is worth making sure that you've got them sorted, and they do tend to come up in every single exam. So we'll start by looking at the question. A sample of rhenium is ionized by electron impact in a time of flight mass spectrometer. A 185 Re plus ion with kinetic energy this many joules travels through a 1.45 meters flight tube. The kinetic energy ion is given by the equation K equals half mv squared. Calculate the time in seconds for the ion to reach the detector, and we've been given Avogadro's constant. So as with all these questions, you do tend to need to use all the information they've provided. Now, just before you get going, do make sure you write down this formula triangle. If you studied IGCSE or GCSE physics, you'll be familiar, but you'll need it for A-level chemistry regardless. It tells us that time equals distance divided by speed. And that kind of makes sense because we know our final answer will be related to time, but we're in no way ready to get going with that formula yet. We're going to have to do some maths before we get to that point. Look, what's common to both equations is this V. So clearly we need to use this equation to find the V, which we'll then be able to substitute into this to find the all-important time. However, before we get going, the first thing you'll want to do, step 1 I'm calling it, is to find the mass of one ion of 185 Re plus. And we want to find that mass in kilograms. So how do we do that? I'm going to write it out nice and fully. You're going to use the mass number, so that's 185 they've provided you in the question, and you're going to divide it by Avogadro's constant, because what that does is it's taking the mass we've been given and telling us exactly the mass of one ion as opposed to 1 mole of the substance. So that's why you have to divide 185 by Avogadro's constant. And that gives us a very small number indeed. And make sure you get your units converted at this point. We need that in kg, so we divide it by a further 1000. So we're already scoring some marks here. Step 2, use Ke equals half mv squared to find that speed value. So the kinetic energy we were told was 1.153 times 10 to the minus 13. The mass we've just found times v squared. For me, you just want to simplify each side. So just do half of that number you just found. Then to get v squared by itself, you divide both sides by 1.5365 times 10 to the minus 25. So you'll find that to be v squared, and then finally you need to square root that answer to find v to get 8.66 times 10 to the 5. So close now. Right, we are finding time, so we do distance divided by speed. So the distance was 1.45 meters. Speed we've just found. Our final answer therefore for the time is 1.67 times 10 to the minus 6 seconds. So just to recap, make sure you have that physics formula triangle written down. Make sure you're aware that Avogadro's constant means the number of atoms or molecules in 1 mole of a substance. Step 1, you're going to find the mass of simply one ion of your substance, and you're going to do that by taking the mass and divide it by Avogadro's constant, being sure to convert it to kilograms. And that's because we have kilograms being used throughout the question, so we need to keep those units matched up. Step 2, we're going to use K equals half mv squared to find the speed. And then step 3, finally just plugging those numbers into time equals distance divided by speed, and you'll get your final answer here in seconds. Right, let's put this into practice now by looking at this past question. So a sample of strontium is analysed by TOF mass spectrometry. The sample is ionized using electron impact. The ions are accelerated to have a kinetic energy of this. An ion takes 9.47 times 10 to the minus 4 seconds to travel along a 95 centimeter flight tube. I'm just going to label that. That's time, that's distance. And I can see straight away, look, that's in centimeters. I'm going to just pop that into meters so that I don't forget to do it later. Use the information given to deduce the mass number of this ion, and here's Avogadro's constant. Right, so I'm just going to get started then. Here's that all-important triangle. We're kind of working backwards compared with the last question, but don't worry, because we're after the mass number. That was our starting point before, but it doesn't matter. We're actually just going to dive straight in. We know that we have both time and distance, so we're now going to find V, which then we can plug into this equation. That will enable us to find mass, and then we can unfold that mass using Avogadro's constant to find the final mass number of this ion. So the distance I've already changed to meters. So that's your number, meters per second. Then we're using Ke equals half mv squared. We know Ke, we've been told, is 7.02 times 10 to the minus 20 equals half times m, which is what we're after, times this number we just calculated. Make sure that number's squared. Then rearrange. So I'm going to just square that number, divide it by 2. And then to find m, you do 7.02 times 10 to the minus 20 divided by that number. And then last step, to find the mass, you get that number you just found. Make sure you pop in Avogadro's constant down here. And then obviously to find mass, we do 1.39 times 10 to the minus 25 multiplied by Avogadro's constant. So that gives us a number of 0.084 kg. Just be a little bit careful with units. You want your final answer in grams, so multiply that by 1,000 to get 84.